Welcome back for the fourth lecture of this week. So we have been talking about various applications, and we finished our discussions on text summarization. So in the last two lectures of this week, we will focus on one very important application in NLP, that is called text classification. Okay, so we will discuss what are the different applications where this whole approach to text classification can be used, and we will talk about one simple baseline, that is how to use a naive-Bayes classifier for text classification. And we will also spend some time in discussing how do you evaluate your models. So once you have built your system, and how do you evaluate your system. So starting with, what do you mean by text classification, and what are some of the examples you can think of. So text classification, as the name would say, so you are given a piece of text. It can be a sentence, it can be a document, can be a paragraph, or any other unit of text, and you want to classify it into certain categories, and the categories can depend on what is your application. And that's where this becomes very generic problem, because many of the problems in NLP you can treat them as text classification problem. Okay, we will see some examples. So suppose your problem is you are giving a movie review, and you want to find out is the positive review or negative review. Okay, so here are some examples. So this is the field of sentiment analysis. So you have different reviews here, like unbelievably disappointing, and this you would say, okay, immediately is a negative review. Then full of Jenny characters and richly applied satire and some great plot twists, and you will say, okay, this is a positive review. This is the greatest screwball comedy ever filmed, again positive review. It was pathetic, and so on. This becomes a negative review. So now the problem here is, suppose you are given a lot of movie reviews, or say product reviews or hotel reviews, and you have to find out each and individual sentence, is it talking about some positive sentiments for this product or negative sentiments for the product. How do I do that automatically? So this becomes a classification problem. So given a text, I want to classify it into one of these classes, positive, negative, or neutral. Let's take another example. So here this is about authorship attribution. So given a piece of text, find out certain demographics about the author. So what is the gender of the author? Is it a female author or a male author? What is the age of the author? Is it in the early 20s or 30s, or is it a very old author? And there can be many other things, like what is the country that author belongs to. And then you can also go to very fine label to saying, okay, who is the author for this particular paragraph or text. Now, why do you want to treat it as a classification problem? So you will say that authors for a particular demography will have certain traits. Okay, so they will have a particular style of writing. So can I try to see, given a text, what style of writing it matches, and match it to the corresponding class. So here, for example, there are two pieces of text, and the problem is whether this is a male author or a female author. And then you can use certain heuristics and some sort of studies that people have done, that when they are male authors, they will write about lot of different facts, and then female authors, there will be some certain opinions. Opinions will be in majority. So when you see these two pieces of text, and you will say, okay, the first one is talking about lot of different facts about the year information and the place information, and second text is about certain opinions and certain subjective information. And then this might be used to say, okay, which one is the male author, which one is the female author. But in general, when you are given a lot of data about writings from male and female author, you can try to learn a model that can classify a piece of text. Is it from a male author or a female author? So like similarly, so here you have a research article like Medline article, and it can be from any research domain. And what is the problem? For that, suppose for your digital library, you have a set of categories or broad topics, and given a new article, you want to assign it to one of these topics. Okay, so that is putting this in somewhere in your hierarchy of categories. So here, for example, the categories can be antagonists and inhibitors, blood supply, chemistry, drug therapy, embryology, epidemiology. So all these are different categories that you have in your mesh hierarchy. Given a scientific article, you want to put it in one of these categories. So this is again a classification problem. All these categories are your classes, and given a piece of text, you want to find out what is the category it matches to. So you immediately start seeing that this text classification is a very wide problem, and different applications you can always convert them to some sort of text classification problem. So yeah, so like assigning subject categories, topics or genres, this is one category of text classification. Then it can be spam detection. You are given an email, or it can be now tweets, movie reviews or product reviews. Is it a spam or not? Okay, this is a classification problem, spam or not spam. Then authorship identification. So we talked about this, who is the author, find out the demographics of the author and so on. Age and gender identification. Language identification. So that is, you are given a piece of text, find out what is the language it belongs to. So here what is important is that when you are, so for example, let's talk about English versus Hindi. So whether the language is English or Hindi. So what do you think, is it a simple problem or difficult problem? So suppose you are writing Hindi in Devanagari, then just basis on the script you can find out whether it's English or Hindi. But when you type Hindi in your, say, in your comments, Facebook post or Twitter, so do you write in Devanagari or do you mainly use the Roman script? You mainly use the Roman script, okay, and so that is, you use the transliteration for typing in, for writing in Hindi. So that means when you have the English text and Hindi text, they have the same script. So the script is same, so that means you have to go to the actual word label to find out is it coming from Hindi or English, and that's where the problem starts. The same words can be written both in English and Hindi. So same way, for example, take pure in English and pure in Hindi. So they will have roughly the same transliteration, P-U-R-E. Okay, so given this word, it will be difficult to find out if it is a English or Hindi word. So like that, there will be different problems, and given a piece of text, what is the language? There you need to build up some different language specific models. Then there is a field of sentiment analysis. That's what we talked about. Although we will give an entire week for talking about opinion and sentiment analysis, that will be the last week of this course. So let us formally define this problem of text classification. So what do you have? You are given a document. So by document I mean a piece of text. So that is the unit that you want to classify. So in general it can be a sentence, paragraph or whatever. So you have a document D and you have a fixed set of classes C, C1 to Cn. So this document D, you want to classify it into one of these n classes. Of course there can be some variations where you may want to assign it to many of the classes, or so we will talk about that, but that's like the simplistic assumption that each document belongs to one and only one class. So given a document, I want to assign it to one of these classes. This is the text classification problem. Now, so my output will be one of the classes, one of the class from this set of classes. So what can be the simplistic method that I can use? So like many other applications that we have seen, so you can also use some hand-coded rules. Okay, so let us say you have the problem of spam detection. So you have an incoming email and you want to classify into spam or not spam. So what would be the simplistic model? So simplistic model could be, so try to see some sort of spam emails and make some hand-coded rules. Okay, so what is the common spam that you remember? So one would be, okay, so like you have been selected for some $100 million or $750,000 and so on. Okay, this is a very common form of spam email. So you can have some hand-coded rules like, okay, if the email is coming from some blacklist addresses, okay, so suppose you have a list of blacklist either URLs and email IDs. So if it is coming from there, or if it contains something like dollars and have been selected, so then it is a spam. Okay, this is one form of hand-coded rule that you can build by seeing what are the different spams that email that I see regularly. And like that you can try to find out many other spams and build these various rules. Okay, so that is one approach. So like the other application that we have seen, so what is the what are the pros and cons for using a hand coded rules? So pros are that if you are an expert and you can write very good rules, then in general they will be very precise. They will be quite accurate. So you will get a high precision. So whenever you have something like dollars and have been selected, you will probably be it will probably be a spam email. But other problem is that you do not know how many such rules you have to build. So if you do not have sufficient rules, you will not have a very high recall. So you will not be able to find out all the spams. So we'll talk about these evaluation measures, precision spam also in detail during this topic. So maintaining is also quite expensive. So if you do not want to use hand coded rules, what is the other option? So you will use some supervised classification method. And so some very popular methods are like naive Bayes classification, logistic regression, that is similar to what we talked in terms of maximum entropy model. Okay, so what is the probability of a class given an input and a history x? So you will say, okay, this is it's a linear function over the various features, sigma, lambda, I, fi, and then you have an exponent term, exponent of summation lambda, I, fi. So this is a maxent model or logistic regression model. But you can also use other models like naive Bayes model and support vector machines, SVM, and all these require thinking of various features that will be helpful for this particular task. So in these two lectures, we will focus on one model, that is naive Bayes model, and that is one of the very powerful baselines for text classification. So this is the default model that you would use for any text classification task. So we will see what is the naive Bayes model, and we will also do a working example for this. So what is the naive Bayes model? So that is, it uses Bayes rule to do classification of a text into certain classes. Okay, and this relies on a very simple representation of document, that is bag of words. And by now you understand what is a bag of words model. That is, you are given a piece of text. Now in bag of words model, the order in which the words occur in the document do not matter. What matters is that what all words are there. So it's like a set of words. So that is the bag of words assumption. Now what are the other assumptions that naive Bayes model uses? So let us see that model in detail. So okay. So let's quickly say what do I mean by bag of words model for document classification. So assume that you have certain documents with you, and you know also the category. So suppose you are talking about certain research domains, and you want to put all your documents or scientific articles into one of these domains. For example, here you have an article from machine learning, another from NLP, then garbage collection, planning, GUI, and so on. Now these documents will contain certain words. Okay, so what is bag of words model? So you assume that document is nothing but this bag of words. So here all these words that occur in the document corresponds to this document. Okay, learning, training, algorithm, shrinkage, network, etc. This is all the document, and then this is assigned a category of machine learning. Similarly here, parser, tag, training, translation, language, these are all the words that occur in the document, and the document is assigned the category of NLP, and so on for all these documents. Now what is your task? So you know, so there will be some data that is already labeled with these classes. At test time you will get a document, but you do not know what is the class for this document. Okay, so for example, at test time you get a document with these words: parser, language, label, translation, and you do not know what is the class of this document among all these possible categories. So here, based on what are the words that are occurring in this document, you want to assign it to one of these classes. And there you are using the bag of words assumption that, okay, I know what are all the words that are there, and I do not care about the order information. Now once I have this scenario, how do I use a naive Bayes model for classification? So all of you know the Bayes rule by now. So what is the Bayes rule? So it would say that probability of a class given a document would be, so how do you write it? P C given D. Probability of a class given a document is nothing but probability D given C, P C given P D. So, now why are we using the Bayes rule here? C is a particular class and D is the document. Now, I want to find out the probability for all the different classes given this test document, and I want to take the one that is having the maximum probability. So, my problem is take the class that is giving the maximum probability, argmax C in the set such that probability C given D is the highest, and you can also get the maximum a posteriori probability. So, this is the class that you get by Bayes rule. Now, so the question is, how do you compute this probability of a class given D for all the different classes? Now, what is the naive Bayes model? So, if you remember, we talked about two different families of model. One was generative models, another was discriminative models. So, naive Bayes is a kind of generative model. So, that is, it will say that you have the class first and then you generate different documents for the class. Okay. So, what would happen in the model? So, you have the class C and then you are generating the document D from this class. Okay. So, that is, suppose I want to generate a review, it says that first you think that whether you want to generate a positive or negative review. So, class will come first and then for that class you will generate the document. So, that is how the probabilities will flow. So, you can find the probability of a document given the class from the generative model. So, that is why you cannot compute this directly. So, you have to compute probability D given C. So, that is where the Bayes rule comes into picture. So, I want to convert that into probability D given C, and how do I do that? Using the Bayes rule. Okay. So, this becomes argmax over all classes probability D given C, probability C given probability D. And now, because PD is common for all the classes, yes, you know the given document. So, this you can remove. So, this is my this is the probability that I have to estimate, argmax over C, probability D given C, probability of C. What is probability of C? That is the prior probability of the class. How much this class is prevalent in this collection. So, this is, if I do not know about this document, what can I say about which class is more probable than other? This is the prior probability. And then this tells you, given this data, when you have seen the document, then what is the probability of document getting generated from this class. Together they give you the posterior probability of class given the document. So, so PC you can easily compute, right? If you are given a training data, you can find out how often this class C occurs among all the classes. Now, how do you compute probability D given C? Now, for that you have to see what is your document. Your document is nothing but bag of words here. Yes, it is a bag of words. So, suppose the document contains some words x1 to xn. So, then you can convert D to x1 to xn and you can write like, so this is same as argmax over C, probability x1 to xn given C, probability C. Okay. And where x1 to xn are various. So, in general you can call these as various features. If you are only using your words, then features will be only words. If we are using some other information like it can be maybe the time of the document or the length of the document and many other things, then this is also possible here. So, this is that you get by this simply using the Bayes rule. So, now you have this. So, again this one is easy, but this is might be difficult to compute. What is the probability of getting all these features together given this class? And that is where you make in naive Bayes assumption. Okay. So, this is the naive assumption that is why this is called a naive Bayes model. So, what is the naive assumption here? So, that is the probability of all these features given the class can be written as, so this whole thing can be written as multiplication of probability xi given C for all xi. Okay. So, that is each feature is conditionally independent of each other given the class. So, this simplifies this model to a very large extent. So now you do not have to worry about the joint probability of all the features. You can talk about the individual probability of different features, and then you multiply. So this is the from the naive assumptions. And that's where you are using the Bayes rule. Okay, and together that's why this is called the naive Bayes model. Okay, so you know what is the naive assumption here, and then you are using the Bayes rule for computing this probability. So now if we go back, so we want to compute find out the class that gives the highest probability C given D, and then we write using Bayes rule in this form, and then we said document D is nothing but all the features that are there in the document. So this is collection of the features x1 to xn given the class C. Then how do you compute probability x1 to xn given the class C? So there you are making two assumptions. One is bag of words, that is the position of a word in a document does not matter. Okay, so x1 and x1 to xn, whatever order they occur, is immaterial. So I only am talking about a set of words here. And then what is the other conditional independence, the naive assumption, that the feature probabilities xi given cj are conditionally independent of each other given the class cj. So I can write probability x1 to xn given ch, probability x1 given c times probability x2 given c up to probability xn given c. So now I have taken all these assumptions, and now this I have a very simplified model, that is I will take the class that gives the maximum the argmax over pc times px given c, and x here are all my different words. Now the next question is, how do I compute these probabilities from my training data? So how would you compute probability C? So PC would be what is the probability of this class in the training data. Okay, so that is in my training data, how many documents have been labeled with this class. Okay, so this is doc count C is equal to Cj. How many documents in my training data are labeled with this class, divide by how many documents do I have in my training data. So this is what is the probability of this class in my training corpus. Then how do we compute probability xi given cj, probability of a word given the class, and that will again be very easy, similar to what we did in the case of language modeling. So number of times this word occurs in the class divided by number of all the words that occur in that class. So that is number of times this word is occurring, wi occurring in class cj, divided by all count of all the words occurring in class cj. This can also be taken as the whole corpus count of class cj. How many unique, not unique, how many different total tokens are there in this class cj. So this will give me both the probabilities, and then I can, so this I can estimate from my training data. So I have these probabilities, I can multiply these and get the best class for a given test document. So what can be one problem with this approach, with only taking these probabilities as such? So assume that in training data all the classes occur at least once. So this the prior probability of a class will not be 0. Okay. But what about this particular term, probability wi given cj? So suppose you are given a test document, and test document I mean there are different words w1, w2, w3 and so on. There is a word wi that does not occur in training data with class cj. Okay, but all the words they occur some number of times with class cj. So what will happen with my estimate of the posterior estimate? So this will become probability of cj times probability wi given cj for all I. Now while all the other wi are having a positive probability, this one is giving me 0 probability. So if you multiply this, everything becomes 0, irrespective of even if the other words were very highly suggesting that class cj. So, only one word, if it does not occur in that class, it will make this whole probability go to 0. So, that means we need to do something to avoid this scenario, and what should be that we will be doing, and so that will again remind you of what we did in the case of language model to avoid these zeros. So, we do something like a smoothing. So, we use the smoothing to get these counts, get these probabilities. So, how do I use smoothing? So, till now I am computing probability W I given C j h. So, right now this probability is computed as count of word I in class C j divided by summation over count of any word W in class C j for all words. That is the current probability, that is the MLE, maximum likelihood estimate. Now, how do you use smoothing? Suppose I use the simplest smoothing, that is add 1 smoothing. So, I will now write it as plus 1. In the denominator, I will have to add 1 to all the W words. Okay. So, this will be plus V, where V is my size of vocabulary, and this will be now add 1 smoothing, and that is what I will be using. So, once I do that, this will have some small probability 1 by V, and this whole thing will not go to 0. So, that is what is the problem with simply using maximum likelihood estimate. So, suppose in your training data, we have not seen the word fantastic in class positive. So, you know this probability will be 0, probability of fantastic given positive will be 0, while other words in the review of the sentence might indicate positive. So, this whole thing will go to 0. So, instead we use a add 1 smoothing. So, count plus 1 divided by summation over count WC plus 1, that will give me a plus 1 in the numerator and plus V in the denominator, and that is my add 1 smoothing. So, we talked about the naive model and how do we compute various probabilities, and we saw one problem with the probabilities, that some probabilities might go to 0, and that will take the whole thing to go to 0. So, that is why we can do a simple add 1 smoothing. So, now in the next lecture we will take an example and see how do we actually compute all these different probabilities from a simple training data, and we find the probability for the test sentence or document.